So see guys, today we're talking about one of the very interesting concept in wave motion. So this is regarding your wave motion. So wave motion is one of the chapter wave motion. So in the wave motion, so very important concept is Doppler effect. So what is the Doppler effect? Let's see guys here. So we take a sound source. So this is the sound source. So this is the sound source. So this is the sound source guys. So so this is the actual original frequency. So original frequency. So this is the original frequency. So somebody there here that is observer. So observer is there. So observer is there. So observer what will be lesion? Apparent frequency lesion. So this is apparent frequency. So apparent frequency. So waves moves like the change in original frequency to apparent frequency. So there is a little bit change with respect to relative motion. So that change, let us say this is F4, original frequency, and this is FA, apparent frequency. So delta F is equal to FA difference F. So FA difference F. So delta F is equal to FA difference F naught. So nothing but we know V is equal to F lambda. So V is equal to F lambda. So according to that, so the wave velocity never changes. So F is equal to V by lambda. So from this delta F is equal to V by lambda 1 minus V by lambda. I hope people are right. So what are the common here? V is the common. So 1 by lambda 1 minus 1 by lambda. So that is delta F. So this is the change in frequency. So I want to find out the change in frequency. Simple, we have to take frequency difference. So that is Doppler effect. So Doppler effect is nothing but when the original frequency wave is moved forwarded. So apparent frequency. So this apparent frequency is always less compared to the original frequency. Generally, when train is moving, train is we are there and train also there. Both of you on same point. So you get more sound. So once train is leaving from your point, automatically the sound is reduced. So that is nothing but a Doppler effect. So in the Doppler effect, I want to find out if a apparent, I want to find out apparent frequency. So that is the apparent frequency Fa is equal to F naught into V plus R minus by V plus R minus Vs. So this is very important form. So every year in IIT, so we will get this question. Generally in IIT, we will get these questions. So IIT will get Doppler effect, at least one question will get. So that things leads to the Doppler effect. So in general IIT question, Doppler effect, we have to see from last couple of 10 years question paper, you people. So we get Doppler effect question, Doppler effect. So let's see Fa is equal to F naught into V plus R minus F naught into V plus R minus V naught by V plus R minus Vs. Let's see guys here what is Fa stand. So Fa nothing but apparent frequency. Apparent frequency. What is F naught? F naught means original frequency. So original frequency. What is V stand? Velocity of the wave. Velocity of wave. V stand what guys? Velocity of wave. V naught is equal to velocity of observer. Velocity of observer. So V naught is equal to velocity of observer. Next, Vs is equal to velocity of source. So velocity of source. So that is the terminology. So Fa is equal to apparent frequency, Fo is equal to original frequency, V is equal to velocity of the wave, V naught is equal to velocity of the observer, and Vs is equal to velocity of the source. Now I want to find out the F naught first. Suppose there is a harmonic is there. Suppose I take a string of length L. So I take a string of length L. I am doing with the first harmonic. So I do with the first harmonic. So I want to find out the frequency of that first harmonic. So let's see guys, here is node is formed, node out. Here is node is formed, and here is antinode, and here also what guys, antinode. So from this point to this point, what is the wavelength? Wavelength is lambda by 2. So wavelength is what guys? Lambda by 2. So now what is L is equal to, from this diagram, L is equal to lambda by 2. Lambda is equal to how much? Lambda is equal to 2L. Lambda is equal to 2L. So lambda is equal to 2L. So we know what is the V velocity? Velocity is equal to F lambda. So velocity is equal to F lambda. From this, F is equal to V by lambda. V by lambda. So what is the lambda value guys? V by 2. So lambda already found here. V by 2. So we know 1 by 2L. So this is a progressive transverse of waves. Crust and trough na. So when crust and trough is formed, what is the meaning of it? So in the wave, there is a crust and trough is formed, nothing but a transversal wave. So what is the transversal wave velocity guys? Speed of the transversal wave how much? So the speed of the transversal wave is that root of T by mu. So tension by mass, linear mass density. So that is mu. So like this I go with second harmonic. So first harmonic is over. I am going with the second harmonic. So second harmonic is entered. So this is the second harmonic. So node is formed, and node, this is antinode, and this is also antinode, and antinode, and this is what guys? Node. Now what about L? So from this node to this node, lambda by 2, node out. Plus this node to this node, how much here? Lambda by 2. So finally what is that? 2 into lambda by 2. I want lambda by 2. So lambda is equal to 2L by 2. Lambda is equal to 2L by 2. Once again apply the formula. So keep in mind that this is very important formula. So we have to remember e-paper. Once again come back. First we have to find out the F naught. So lambda is equal to 2L by 2. So once again we have to substitute in this equation. Let us say this is F1. Now we want to find out F2. Otherwise we go with F0. Better F0. So let us say F1. So F1 is equal to, what is the formula guys? V by lambda. So what is lambda? This is lambda 1. Let us say lambda 1. Better to understand. So this is also V lambda. So this is F0. We change all these things now. So F0. So V by lambda 1. So V by, what is lambda 1 guys from this? Lambda 1 is equal to 2L by 2. So 2 into V by 2L. Already 2 into V by 2L means what? So 1 by 2L into root of T by mu. So nothing but what? 2 into F0. So like this, suppose P harmonics I did. So I did how many harmonics? P harmonics I did. So last I go with the Pth harmonic. So observe guys here, F1 is equal to 2 into F0. So Fp is equal to how much you get? So P by So 2. First what you get? 1 you get. Now what you get? 2 will get. So P by 2L root of T by mu. Otherwise P by 2L into mu. So either we have to get. So very important formula. So Fp is equal to P by 2L into V. So Fp is equal to P by 2L into V. So this is the way we get the frequency of pth harmonic. So what is but a harmonic? Nothing but this is an harmonic. First harmonic. This is what guys. Second harmonic. First overtone. Keep in mind. So this is what first harmonic. This is what second harmonic. Second harmonic. Second harmonic. But first overtone. Keep in mind. First overtone. This is first overtone. This is what here? Second harmonic. So this is the second harmonic, this is the first overtone. So first overtone. So this is first overtone and second harmonic. So like this you have to find out the frequency. So no issue at all. Now comes to our apparent frequency. So how to calculate apparent frequency? We will get a formula for original frequency. And the problem is given how to calculate a original frequency based upon the harmonics. Now our issue that what is the formula guys? So F apparent is equal to F naught into V plus or minus V naught by V plus or minus Vn. This is the formula. So let's see the first application. So how to apply this formula? So application 1. So application 1. What is the application 1? Source is fixed. So source is stationary. Source is stationary. Observer is moving towards source. So let's see this case. Keep in mind guys, velocity of the wave always move from source to observer. That is very important. So keep a note, velocity of wave always move from source to observer. So velocity of wave always move from source to observer. This is very important. So very important. So velocity of wave is always move from source to observer. So that is very important. Keep in mind deeply. So let's apply this formula. So this is the source Vs. So Vs. So this is observer. This is stationary. Stationary means what is the velocity? 0. So observer is moving towards the source. So observer is moving like this. So this is the observer. What about wave velocity? So wave velocity is always move from source to the observer. So source velocity is 0. Observer means observer according to this question towards the source. And what is the velocity? Velocity always move from where to where? Source to the observer. Now we have to apply this formula. So F apparent is equal to. So what is the formula guys? F naught into. Let's see here. What is the relation between V and V naught? So V is moving in this direction. Understood I hope. So V is moving in this direction. But V naught is moving against that direction. We know the relative motion. According to the relative motion, what is the formula? V plus V naught. So keep in mind guys. So velocity is moving in this direction, velocity of the wave. What about observer? Observer is moving against the velocity of the wave direction. So what you get? V plus V naught. So next V comma Vs. So anyhow Vs is 0. Source is stationary. So what you get? V only get. So now we have to implement the formula. So V plus V naught by V. So very important formula. So F apparent is equal to F naught into V plus V naught by V. Go to the application. Application 2. Let's see the application 2 now. So application. So what is the application to source is stationary, no doubt. Source is stationary only. But what about the observer? Observer is moving away from the source. Away from the source. So away from the source. Let's see the diagram. So diagram is very important for Doppler effect. So Doppler effect. What is Doppler effect? Already I told. So this is the sound source. Somewhere else observer is there. Some observer is there. Some observer. So observer is moving away from the sound source. So observer is moving in this direction. Let us say Vs is fixed. That is the stationary 0. So already told, velocity of the wave always move from source to the observer. That is very very important. So velocity is source to observer, source to observer. So this is what V direction. So this is what guys V direction. Once again we have to look into Vs comma V, Vs comma V. So Vs comma V. Once again no issue. So once again V1. Why? Because Vs is remain 0 only. So next one is what? So relation between V and VO. So V and VO. V is moving in this direction and observer also moving in this direction. Both are same only. So what we got? So V minus V naught. No doubt. So finally what is the formula we got for this example? So Fp is equal to F naught into. So what is got? V minus V naught. So V minus V naught by V only you get. So this is the formula for source is stationary, observer is moving away from the source. Observer is moving away from the source. Observer is moving away from the source. So away from the source means this one. So this is away from the source. Next application 3. So application 3. Application 3. So what is application 3 guys? Let's say application 3. So this is the source. So this is the source. So this is the source. This is an observer. So observer is towards the source. Source is towards the observer. Source is towards the observer. And observer is towards the source. Observer is towards the source. Common. So what is the velocity of wave? Velocity of wave V. V always move from source to observer. That is very very interesting. So V always move from source to observer. So now I want to write down. What we have to write down? So relation between V comma VO. So what is the relation between V and VO? So V is moving in this direction. VO is moving against the velocity of the wave. So what we got guys? V plus V naught. Next, source is moving in this direction. Velocity of wave also moving in the same direction. So what is the relation between V comma Vs? So V comma Vs is equal to V minus Vs because of same direction. So velocity is moving in this direction. Velocity of the source moving in this direction. Velocity also moving in the same direction. So what do you get? So V minus Vs you get. Now I want to find apparent. So F apparent is equal to F naught into V plus VO by V minus. So this is the formula for this. So next case, application 4. Let's say the application 4. So application 4 is what? So application 4 is what here? So application 4 is that. Application 4 is what? So application 4 is what here? So application 4, app 4. So what is app 4? Let's see, this is the sound generator, sound source. So Vs is moving away to the observer, and observer also is moving away to the source. Both are moving away from each other. So when both are moving away from each other, so velocity of the wave is this direction. This is the velocity of the wave. So velocity of the wave always move from source to the observer. That is very, very important. Keep in mind, guys. So now, what is the relation between V comma V1? So observer is V comma V1. So velocity of the wave move in the direction, and velocity of the observer also same direction. So what you got? V minus V1 and V to Vs. V to Vs. So from V to Vs, so Vs is moving in the direction, velocity of the wave is moving in the direction. Both are different directions. So both are different directions. What you get? So different means V plus V. Now we want apparent frequency. So F apparent is equal to F naught into, so V minus V naught by V plus Vs. So this is an example for application 4. Now let's see another application. So now we move on to the application 5. Application 5. So application 5 is application 5. So what is the application 5? Let's go. So source is moving in the direction. So this is Vs. So Vs is moving in the direction, and observer is moving in the direction. This is observer. Observer moving in the direction. So source is moving in the direction. So observer moving in the direction. So now what about velocity of the wave? Velocity of the wave always move from, tell me guys, move from source to observer. So now let us say theta 1 is the angle meeting. Theta 1. So this is what, guys? Theta 2. So we have to compound resolution. Once again, compound resolution from this. So what you get? Vs cos theta 1 here observer, VO cos theta 2. I hope people are understood. Compound resolutions. We don't know this concept. So go through physics in 24 hours playlist. We have to see the one of the concept compound resolution in vectors. Go through that video, please. So now once again, V comma Vs. So V comma Vs. So V comma Vs. So Vs is moving the directions. So this is V now. So V is moving in the direction, and V is also moving in the same direction. So what you got? Same direction na? V minus Vs cos theta 1 you get. I hope people are understood. So next, so V is moving in the direction and V naught is moving in the direction. Observer is against the velocity of the wave. So V comma V naught. So V minus V naught cos theta 2. Cos theta 2. So but it is in different direction. So we put what? Plus V naught. V plus V naught cos theta 2. Now you write down that formula. So F apparent is equal to F naught into V plus V naught cos theta 1 by V minus Vs cos theta 1. Cos theta 1 or 2? Cos theta 1. So Vs is cos theta 1 like that. V naught is cos theta. Yes. So So this is the formula for when the scenario like this. Let's see the sixth scenario. So this is very very important actually. We look for that one. So very very important scenario actually. So we want this one actually. We look for this one. So a wall is there. Stationary wall is there. A wall is the stationary, and it has some road, and a car is traveling on the road. A car is traveling on the road. A car is traveling, guys. The driver is there here. Some driver is there. So driver blowing the horn. So now I want to find out the apparent frequency. So in this scenario, we got two cases actually. Let's say the case one. So let's say the case one. I am demonstrating case one. What is case one, guys? Who is the source now? So driver blow the horn. So this is the Vs. Vs is traveling in this direction. Clear? All of it clear? So the sound wave will beat. The sound wave will beat the wall. So now who is the observer? So wall is an observer now. So wall is an observer. So which means station. I told you always the sound wave move from where to where? Source to the observer. So source to the observer. This is V. This is V. Source to observer. Now apply the formula. So let us say F2. We go with the F1. F1 is equal to F0. So let's say guys here once again look there. So V comma VO. So what is V comma VO? So V comma VO. So what you got? VO only you get. Why? Because V0 is stationary. So that is 0. So next V comma Vs. So source is moving in the direction. And the velocity of the wave also in the same direction. So what you have to got? V minus Vs. Both are same direction only na. So finally what is the formula you get? V by V minus Vs. Let us say equation 1. See the second scenario, totally changed I hope. Now second scenario, so we not. Now second scenario, so now wall have a sound that reflected to driver. So this act as what? Vs act as what? Source. And these sounds will observe by this driver, let us say VO. And what is the velocity direction, guys? Velocity direction is always source to the observer, but observer is moving towards the source. Yes or not? Is moving like this. So power is traveling like that. Power is traveling. So I hope people are understood. So the observer is moving towards the source. Source is at stationary. Now comes to our same thing. So V comma Vs. So V comma Vs. So Vs source is stationary. So V only. And V comma V naught. So V comma V naught means so the observer is moving in this direction. But source is against to the observer. So what you have to got? But what is the frequency? Frequency is F1, keep in mind. Frequency is F1. Now we want to calculate what? F2. So F2 is equal to, what is the frequency? F1 into, so V plus V naught by V. Agree or not? V plus V naught by V. So F1 already we know from equation 1. We have to substitute here. So F0 into V by V minus Vs Then V plus V naught by V. So V cancel. So what you have to got guys? So F naught by V plus V naught by V minus V. That is F2. So very important formula. Maximum IIT. Maximum IIT means we got a Doppler effect from application 5 only. Thank you guys.